Assalamualaikum and very good day to everyone. My name is Nurul Aini from Master of Communication Engineering. Today I would like to present my final report for my Dissertation B, which regarding the topic of Mmwave Carrier Generation for IoT Application. This thesis was supervised by my supervisor, Professor IR Dr. Shamsuri Yaakob. The presentation outline will be 6 items: project background, research problem, project aim and objectives, project scope, methodology, result and discussion. So for the project background, basic ROF mainly consists of center station, optical fiber and base station. The generation of millimeter wave is defined by CS using modulator to modulate radio frequency on light waves, where millimeter wave is transmitted through optical fiber and the signal is transmitted through antenna. This view focuses on a variety of different millimeter wave carrier generation technique, specifically for IoT application, and the importance of identifying the best parameter that contribute to the millimeter wave carrier performance. Congestion and limited frequency spectrum has affected data rates of current wireless system. So to achieve high data rates, the solution is bandwidth and the use of millimeter wave frequency. Millimeter wave frequency has better efficiency due to its large bandwidth and data can be transmitted at rate of gigabit per second. Another thing is the best regarding millimeter wave is it can be used without authorization internationally. So it has more spectrum. The beam wave of a millimeter wave is also very narrow and good directivity in space propagation. The antennas is miniature in size, which very helpful for installation and maintenance. And millimeter wave have very high frequency and large broadband, so it can transmit data with large capacity. So how do we generate the millimeter wave? It started from optical generation of millimeter wave signal, and then we go to the carrier, where the carrier using optical fiber is the ideal medium for millimeter wave transmission due to its low loss, low cost, and wide bandwidth. The technology that has been used is ROF technology, which optical component and technique to allocate RF signal from central station to base station. So there are 5 techniques that has been discovered from this study. Number 1, direct intensity modulation technique. Number 2, external modulation. Number 3, up and down conversion. Number 4, optical heterodyne. And lastly, optical transceiver. So the research problem is a concern on current 4G technology, sometimes used for IoT communication carrier. So 4G is the 4th generation of the mobile network technology. Even 4G could offer very fast and secure internet connection, but it is still congested with the gap between 4G that offer extremely fast coverage with low latency. Below are research problem identified. So there are 3. The first one, lack of bandwidth in conventional system for Internet of Things application due to many nodes involved. The second one is IoT communication sharing spectrum resources with standard smartphone traffic or other devices that may increase possibility of interference. And lastly, current 4G are sometimes used for IoT communication carrier. So that is the old one. So the project aim and objective, they aim to investigate ideal millimeter wave carrier generation suitable for IoT application. The 3 objectives that is been targeted in the thesis is to simulate millimeter wave for IoT application for various band, which are 20, 40, and 60 gigahertz. Secondly, spectrum management review for various IoT application in optical millimeter wave environment. And lastly, optimization of radio frequency spectrum for dedicated IoT application network. These are the method of the millimeter wave carrier generation tree diagram. So as we can see, the technique here we have 5 techniques, which I have opted for the project. It is the external modulation. The project scope that has been distributed in the project is first one, we focus on the backbone stage of the IoT infrastructure, the physical layer, which is the system connectivity for transmission. And then the simulation to identify channel performance, monitor and record performance parameter, such as diagram, bit error rate, and also receive optical power. The generation of millimeter wave for IoT application within unutilized and free spectrum, which I've tested 20, 40, and 60 GHz by external modulation technique. The fifth one limited to only one category of new radio cases application, the new 5G application, which is for MMTC, the massive machine type of communication, which covers the application with a lot of number of devices, sensors, meters, and also remote equipment monitoring. And then this will be using OptiSystem simulation that we can see after this. The IoT application that have been mentioned just now is MMTC, so it's probably can be designed for this application, like post-terminal, parking spaces, home video, transportation, shipping, and energy distribution. So in the literature review, I have compared 5 modulation technique and the generation technique, which are optical heterodyne, external modulation, optical transceiver, up and down conversion, and direct modulated laser by advantage and disadvantages of each technique. So it can be seen for external modulation, the advantages that we have is simple configuration, low cost, good performance, and high frequency. Where the disadvantages, it has complicated light source, high RF return loss, frequency limitation, and sometimes require high drive voltage. The example of technology is MZM, cascaded parallel MZM, frequency decoupling with dual parallel MZM, and so on. So the overall framework that has been followed is was from the start to the end. The start from designing the generation system method, the component for central station and base station, and then the simulation by using the 3 frequency, 20, 40, and 60 by using external modulation, and the generating of millimeter wave at the bit frequency in photodiode. So after that, the result is being recorded and the performance is evaluated by the BER diagram through the Q factor values. So the performance analysis is has been monitored for different parameters, and the overall performance analysis is obtained. I have compared the system using optical transmitter design and also COM transmitter design just to compare on the result. So this is the simulation model of millimeter wave carrier by ROF system, which bit generated using PRBS generator. To the pulses is obtained using non-return zero pulse generator, and then millimeter wave or photonic is obtained from the modulator output. Output is fed into the Mach-Zehnder modulator and then transmitted to optical fiber with various lengths. So here I'm using 5 10 and 15 kilometer, just for the comparison. And then optical amplifier, and then I filtered the link by using Gaussian optical filter, and signal and filtered output is fed to a pin photo detector. So optical signal is converted to electrical signal and the output is obtained. So here is the result from the three different frequency, 20, 40, and 60 gigahertz. So we can see an open eye correspond to minimal distortion. Distortion happen due to interference and noise. For a good signal reception, minimum Q factor is 6. So it was observed in this simulation that the Q factor increased by higher frequencies applied. So to be just a comparison, I simulated also the simulation model of millimeter wave carrier by COM transmitter. So the bit is generated by PRBS, and then it has been modulated by the MZM as well, using the EDFA, which function to boost the data signal, and also transmitted by optical fiber with the same length as ROF just now, 5, 10, and 15 kilometer. And then here we are using the same filter, which is Gaussian optical filter, through the photodiode as well, and the output is fed to is converted to electrical, but here I'm using the monitoring by electrical constellation visualizer, RF spectrum analyzer, oscilloscope visualizer, and BR analyzer. So here is the result of the simulation. Just now I tested the outcome by 16, 32, 64, and 256 COM transmitter. Higher order modulation is good on sending more bits per symbol. This is modulation technique such as higher COM supposed to show an improved Q factor. However, I have obtained a lot of interference from the noise that were affecting the performance of eye diagram, which the higher COM I applied, the less Q factor I achieved. So that is the result that has been achieved for this project. So the conclusion is among many techniques that has been designed for the millimeter wave generation, the external modulation is the popular technique and reliable in designing millimeter wave carrier. So that is all for now. Thank you so much. Have a good day.